going to record the water bottle.
Yeah, me too.
Actually, the homework was really easy.
That's exactly why I have this almost done with a 7.18.
Except for 2 problems on last night's homework.
Yikes. Did all of us its homework?
Nothing? 27?
Ask him then, because he's saying there's nothing.
Because I don't remember what question it was because I leave my notebook at home. You secretly just want answers.
In the back of the book.
1 and 29.
Trying to figure it out.
Where is my motivation?
That's probably pretty hard.
You have motivation.
No. But my lip and close my eyes. Take me
What are you singing?
paradise. Longview, Green Day.
Oh.
I don't know why. For some reason, in that song, it sounds like he has a slight accent. And it's really freaking cool.
Identity problems do not require 3 columns for homework.
I didn't understand that. I was like, why would it require 3 columns? I just did them.
What are we doing 3 columns for exactly?
Nothing.
What we did yesterday.
There's a video on YouTube.
Yikes.
Subscribe to my YouTube channel. Oh, wait. I'm advertising.
Entertainment before the lesson.
Get you guys to hear me talk. Pretty. What number is this?
It's definitely wrong. 27 means
Oh, yeah, that's one I.
Oh, you're going to be mad. What do you think we should do? Huh?
Oil.
Cosecant of x plus 1, cosecant of x minus 1
yeah.
equals cotangent squared of x.
Oh.
So were you asking, did I copy it correctly? Oh, okay. So what should we do? Foil. These 2 things are conjugates, and when we multiply 2 conjugates,
Take out
first and last. So talk to me. Cosecant squared of x minus 1.
Wait, was this the one I needed help on? No, it was
Okay.
not.
Anything good? Yeah. What's good? Oh, that's, wait a minute, that's that thing. 1 plus cotangent squared of x equals cosecant squared of x. Is that right? So cosecant squared of x minus 1.
equals cotangent squared.
That's just cotangent squared of x.
Did you get 23 done?
We done?
I believe it was 23. I had I can't remember.
23. Not, it's not easy.
Okay. So I wasn't looking at it wrong, and I just okay.
I mean, you can do it, but it's not.
You guys don't want to see my hand?
I don't know, I just like
That's offensive.
This is 23.
Yeah. You can understand where my frustrations were.
23. Step 1. Oh, come on. You always know
Cry.
you always know an option for step 1, right? What's step 1? Sine and cosine.
Oh.
Right? I mean, it may not always be the best step 1, but it's always a step 1. So, all right, so sine of x over cosine of x minus cosine of x over sine of x over sine of x over cosine of x plus cosine of x over sine of x. Wait, she said you were supposed to be in here studying. She didn't say you were supposed to be in here on your phone. I don't need your help.
Right.
I'll kick you out so fast. Plus 2 cosine squared of x. Okay there? Step 2. Common denominator.
Sorry.
Okay. But this all makes sense, doesn't it?
Yeah.
Okay. So what's the common denominator on the top?
cosine x,
Cosine of x, sine of x. What's the common denominator on the bottom?
Cosine of x, sine of x.
Sine of x. So, okay, this is kind of a pain to write, but this is the 3rd time I'm writing it today. So if I can write it 3 times, you can write it once. So sine of x, cosine of x, sine of x, cosine of x.
I definitely just want like whole classroom. Thank you. He won an award, people. Clap him up.
Woo, yeah. The person kicked out of class most often.
When you try to be like disrespectful, he was definitely disrespecting everybody in here.
No, because
He thinks he all that.
Can I tell you what that was? That was the highest grade of the class. Then it went.
It does. It was a legit.
What if it's not?
No, not at first when you said it.
Right? And then
Right,
he said,
like-
what if it's not?
Right.
That's what it was.
It's okay. Wait, what'd you get an award for though? Oh, because you went to that
Very
thing.
cool.
Excellent.
Very cool. All right, sorry. What's the new numerator here? Yeah, we multiplied this by sine of x to get here, so we gotta multiply the top by sine of x, which gives us
Sine squared x.
squared of x. Okay. Then, what's this numerator?
Cosine squared x.
Squared of x. Okay. Down below, this numerator.
Squared of x.
Squared of x and
Cosine squared of x.
squared of x. And we gotta keep including that plus 2 cosine squared of x. Okay. Now what? Combine like terms. Yeah, they all have the same denominators.
That's my soul.
Yes?
Yeah.
So in the top, we can
Smoosh.
combine it into one fraction. So we can go sine squared of x minus cosine squared of x over sine of x cosine of x. Over the bottom, we can do the same thing. Sine squared of x plus cosine squared of x over sine of x cosine of x plus 2 cosine squared of x. Okay, any good news? I would save that first step.
Get
I would
rid
save
of
that
the
first step. But you could do it now, but
I would get rid of it.
is there anything that's good up there?
Everything's the same.
Yeah.
Got another absentee. So if you don't, if I didn't put enough answers on there, just come back to
Do
me.
you see anything here that's recognizable, that's good? Sine squared of x
Sine plus cosine
plus cosine squared of x. Oh,
equals
this
1.
is 1, right? So, sine squared of x minus cosine squared of x over sine of x cosine of x over 1 over sine of x cosine of x. Don't forget the plus 2 cosine squared of x. Okay. Now what's the good news?
Now you can cancel the
The
denominators.
denominators are the same. If the denominators are the same, what happens?
Cancel.
They cancel, they cross out. Remember, if it doesn't click, it would be this times the reciprocal of this. So sine of x, cosine of x would be on the top, it would cancel with the bottom, and that would be done. So the denominators disappear, which now gives us
Sine
sine squared of x minus cosine squared of x over 1.
which is just sine squared of x
So
plus cosine
this
squared
whole thing just turns into this?
of x.
Sweet. Plus 2 cosine squared of x. Now what?
We can combine like terms.
Combine like terms. We got this. So we've got sine squared of x plus cosine squared of x. Serious?
It gets this one.
Happens a lot.
Wow.
Wow.
Just gonna not.
You get this?
That is a whole mess for one.
Put it in my brain.
Cool. No. It's pre-calc.
Makes sense.
Everything that we're doing in trig is pre-calc. Just about. In algebra 2, they get into not that much. I think they have to know what the sine of 30 degrees is. Couple of other little things.
22.
All right, any others? Okay, ready to move on? Away we go.
Don't sleep on me.
Keep that X out. 7.3 or 7.2B?
2B.
2B.
We're not sleeping. Who else said that?
It was there, you had to take it.
Oh my God, oh my God.
Today's the 28th, I believe.
Today is the 28th, I believe.
Do you know?
So, today we continue what we started yesterday, which was the, I forgot the word, verifying identities. Okay? And yesterday we gave you a couple of suggestions, a couple of tools, I think we phrased it, for your toolbox in terms of things that you can use to get from step to step and stuff like that. Okay? Today we're going to add a few more. And to be honest, some of these problems are a little bit more difficult than the ones we were doing yesterday. But once you have a list of, what we give yesterday, about 3 or 4 different things to do,
Yeah.
5, somewhere between 3 and 5 different things to do. And then today we'll probably do about 3 more. Okay? Once you have a list of 6 to 8 things that you can do, somehow or another, almost everything's going to tie in with those 6 or 8 things. But the big trick is going to be, when do I use which? And that's just experience. And that's just doing these again and again and again. And the more you do, the better off you're going to be. Okay? So when we look at this one, and remember what we said yesterday, we want to take one side and turn it into the other side. And we typically want to take the more complicated side and turn it into the less complicated side. So in this case, we probably want to work with the left side, I would agree. Is there anything on the left side that you like?
Sine of it. Because you already have sine of it. I don't know.
Can we factor?
No,
Why not?
because you can't.
Because we don't want to. Can we factor that,
No.
that numerator?
Probably.
What? It's being subtracted, but a lot of times that's a good thing.
You can factor that. Pretty sure you can.
Why can we not factor it?
We don't want to.
Because of the 2. Why is the 2 bad? Because the 2 is not a
Primary number.
factor. What did we factor yesterday? We factored something like 1 minus sine squared of x or something like that, didn't we? Because it's not a square. This we factored as 1 minus sine of x, 1 plus sine of x, right? And that worked nicely because we had sine squared of x, so we could change it into sine and sine. And we had the 1, which is 1 times 1, so no problem. And it works nicely when both of those things are squares. Hence the name of the factoring method,
Square double
difference of
square.
squares. Okay? So it has to be a difference and it has to be squares. So the good news is it's a difference. The good news is that's a square, but the bad news is that
That's a
isn't.
2.
So therefore this can't be factored. Is there anything else that you look at and you go, that's not bad, maybe except for one?
Cosine over sine.
She's in trouble again? No, she's usually in trouble, I understand. Anything up there that is close to something that looks good?
Cosine over sine.
Yeah, the tough thing with that is that we have the subtraction up top. But But these are good things. Keep thinking this stuff. Anything else that's up top that almost looks good, but not quite? Does it look like an identity?
Almost.
Almost. What do you mean almost?
There's a 2 instead of a 1.
So the problem is that it's a 2 and not a 1.
Yeah.
So you're saying that if it were 1 minus cosine squared of x, we'd be happier?
Yes.
Okay. Can we write 2 in another way?
No, I don't think so.
No. Stop looking deep and go back to first grade.
1 plus 1.
1 plus 1 is 2.
Can we write 2 as 1 plus 1?
I guess so.
Let's see what happens if we do. See if it helps us at all.
I feel like it's
Okay, we can put those phones away. We're good. So if we write 2 as 1 plus 1, if we write it like that, first of all, can we? Yeah, we just changed 2
Into 1 plus
to
1.
1 plus 1, okay. Does that help us at all?
Yeah.
Because now
Sine squared x.
we have 1 minus cosine squared of x, which becomes
Sine squared
sine
x.
squared of x. So we have this 1 plus sine squared of x over sine of x. Wow. So we just changed 2 to 1 plus 1, and that actually helped us. Interesting. All right, got another question for you. Yeah. What if we had something like 8 plus 20 over 4.
4 plus 4 plus 20.
Can we do that? How can we do that? Well, we can do a few different things with it, but can we write that as 8 over 4
Plus 20 over.
plus 20 over 4?
Yeah.
Is that okay?
Then
So
2 plus
basically,
5.
remember when we get a common denominator, okay, when we get a common denominator, the reason we get a common denominator is so we can put everything together in one fraction. Can we do the opposite?
Yeah.
If we have a denominator, can we split things up? Apparently, we can. So how can we write this?
1 over sine of x
1 over sine of x
plus sine squared x over sine.
plus sine squared of x over sine of x. Huh. What's 1 over sine of x? Cosecant of x. What's sine squared of x over sine of x?
Sine of x.
Sine of x. It's about as simple as I can get. Let's see what we. Oh,
What?
we got it. So right there, we tossed out about two new things that you can do, right? You can rewrite numbers however you want. You rewrite 2 as 1 plus 1. And then this is probably a bigger one that we'll use, is this splitting apart of a fraction occasionally, especially when we're hoping to get two different functions. So like right here, it's kind of like, what do? We have a common denominator, let's split it apart. Can we do that with a denominator? If we have one term in the numerator and two terms in the denominator, can we split them apart?
No.
No, we cannot. We can only do that when there's one term in the denominator. Now, if there are 3 terms in the numerator and 1 term in the denominator, can we still do that?
Yeah.
Yes, we can. The key is 1 in the denominator.
How did you get sine of x from sine squared of x over sine of x?
Here,
Yeah.
from there,
No. The
here.
bottom one, yeah. How did you get to sine
This
of
is
x?
where we just split it up. We just did 1 over sine of x plus sine squared of x over sine of x.
Right, but then how did you
Down
get
here.
to sine of x?
Here, got it. We have sine squared. So it's kind of like having n squared over n. We have n squared over n. What happens? basically, remember that sine squared is sine of x times sine of x. So if we have sine of x times sine of x, and we zap one of the x, the sine of x's, we got it. Okay. All right. Next one. Oh, I already wrote it brown. That means we got to go to black. How about that one? Cosecant of x plus cotangent of x equals 1 over cosecant of x minus cotangent of x. Let me make sure that's right. Hang on. Cosecant plus cotangent equals 1 over cosecant minus cotangent. Yep, we're good.
So I'm not,
You don't like this one?
so I'm not going to have to erase my pen.
The first question is, which side do you want to work with?
Neither.
And this is one where, for me, I would prefer to work with the right. Because to me, the right is more complex. And I would much rather take something more complex and simplify it than take something less complex and try to make it bigger. It doesn't usually work real well. Okay? So now you may come across times where instructions say something like, make the left side, turn the left side into the right side. And in that case, there's nothing you can do. You have to work with the left side. But in this case, they're saying verify the identity. So we can work with whatever side we want. So I would pick the right side. So we got a couple of options here, but I'd like to give you something new that you can use. All right? And you actually know what this is. You've used it before. You haven't used it with trig functions, but you have used it with radicals. You've used it with imaginary numbers. When you rationalize denominators, what do you use? When you rationalize denominators. We've actually used the word recently, conjugate. Sometimes it will be in our best interest to multiply by the conjugate of the denominator. Let me show you how that works here. So what would be the conjugate of the denominator here? Cosecant of x plus cotan of x. So same two terms, just change the sign, right? What would we multiply the top by? The same thing. Why the same thing? Because we have to be multiplying by 1. And by multiplying the same thing on the top and bottom, we're essentially multiplying by 1. Does that make any sense? Why did I do what? Why did I do plus? Because that's minus, and so we want to multiply the conjugates. Now, why do we want to multiply the conjugates? It doesn't cancel out, but watch what happens. When we multiply this across, what do we get? Cosecant of x
Plus cotangent of
plus
x.
cotangent of x on the top,
over
and on the bottom we get
cosecant of x.
cosecant squared of x minus cotangent squared of x, because it's the whole, remember what happens when we multiply two conjugates? Just the first and last, because the oi cancels. Right, we have cosecant of x cotangent of x minus cosecant of x cotangent of x. So those would cancel, which leaves us with this. Is there anything good with that? The bottom. Oh, is that one of those thingamajiggers? Pythagorean identity, that's right. Let me think. The tangents were on the left, and the secants were on the right. So we got that. So cosecant squared of x
So it's 1.
minus cotangent squared of x.
Is 1.
That's just 1. So that gives us cosecant of x plus cotangent of x over 1, which obviously is simply cosecant of x plus cotangent of x. Let's see. Oh, got it. go. There we go. How do you know what to use? That's the problem. Not the problem. That's the challenge. Challenge is a much better word than problem. Because I feel confident that if you had in step 1 changed everything to sine and cosine, that you would have gotten there. It just, probably my guess is it would have taken a little longer, but you can still get there. But I'm just trying to give you other different things that you can use, that you can pick out and stuff like that. By the way, what's the answer to this problem? Yeah, this whole thing. This whole thing is your answer. So on a test, I'm not going to say, okay, verify the identity, what's your answer? Because that doesn't make any sense. I will say verify the identity, and then I'll give you space and I'll look at what you did. Does that make sense? Cool.
So we're still gonna have to work over there.
Probably not on those. We'll see. I actually kind of get bummed erasing these huge problems. I feel like we've done a lot of work to get there, and I don't like to throw things away, so I feel like I'm just...
I feel that.
But, oh well, it is what it is. All right, let's do one more. What do I have? I've got about 9 minutes.
Do you do the same problems all day, or do you just switch it up?
Sometimes I do, sometimes I switch up 1 or 2. Sometimes, like in first hour, I don't like one that I did, and I'll change it for second hour. Sometimes it depends on time, too.
So like first hour might get a different problem than us, but
Possibly, but more often than not, I'll pick the same ones. When I'm taking them out of the book, I'm more likely to do the same ones. When I'm just making up stuff as I'm going along, it's usually different, because I don't remember everything. I'll be in the ballpark, but cosine squared of x over
Over.
1 minus sine of x.
When you said cosine squared of x, did you mean cosine?
What did I mean?
You said cosine.
Yes, and I did mean cosine. I apologize. I know.
I don't like it when you make mistakes. Because I have to use the
That was a
pen.
typo, that wasn't really.
Typo.
Okay,
Did you forget?
which side do you want to work with here?
Left.
I would agree. I see a couple of different things you could do right off the bat. One of them I think works out cleaner than the others, but I see a couple of different things that you could think of that might make it work. Okay? So what do you think?
Change the side, sine, 1 minus sine.
Change the top
Yeah.
to what?
1 minus sine.
1 minus sine squared of x. That, I believe, will be the easiest way to do it. What would another way have been, possibly? What did we just do? Conjugate? Did you say that? I didn't hear it.
I'd rather do the other one.
Well, and, yeah. For me, the conjugate is one of those last-ditch effort type of things. If I've got nothing else to do, I'll throw the conjugate up there and see what happens. But for this one, you're saying you want to take cosine squared of x and turn it into
1 minus sine squared of
1
x.
minus sine squared of x. Remember when we first did that trig identity, and I said you're actually probably going to use the other versions of it more than you use sine squared of x plus cosine squared of x equals 1?
Yeah.
You see why I said that? You can
Yeah.
see that, I mean, we've used it a couple times already. We used it here, we used it there. It pops up quite a bit. All right, now what?
Now what am I doing here?
Doctor.
Oh, factor.
Oh, factoring.
Here we have squared, here we don't have squared. If we have something squared and something not squared, factoring usually will have something to do with making the next step work. So, what do we got? 1 minus sine of x, 1 plus sine of x, over 1 minus sine of x. Ooh. Which gives us got it. I always love when we get to a spot and you look up and you go, ooh, that's it. And you're done. And the nice thing here is that when you're done,
You're done.
you know you're right. You know what I mean? Like you might take an extra 2 or 3 steps to get there, that's possible. But if each step that you take mathematically is correct, and then at the end you get the same thing on the left and right, you gotta be right. Yeah, exactly. You gotta be right. Yes, sir.
So, I'm not saying I would ever do this, but like,
That's not a great answer.
the ratio needs to be multiply out the denominator, because with that, no, never mind, forget what I said.
Were you basically saying multiply both sides? And remember, that's what we said yesterday, that we're not allowed to do that. We're not allowed to do the same thing to both sides, because we're trying to verify the identity. We're trying to verify the fact that they're equal. And if we multiply both sides by something, we're saying, yeah, it's the property of equality. And we can't use a property of equality if we aren't sure yet that they're equal. So, does that make sense? Tonight you got a bunch of these, probably 30 of them, I think. Just kidding. Just kidding.
How many is it?
10-ish. And then at the very end, no. And then at the very end, the last question, I think we talked about this a little bit yesterday. The last question is the one that says, is this an identity? Is it a contradiction? Or is it a conditional equation? Did we talk about what those are?
Yeah.
So the identity is exactly what we just did. The contradiction is going to be, we go through it and they're not the same. And the conditional equation is going to be, it's true if x equals pi over 6 or something like that. So, there's only one of those. So, all right. Anything else? Any questions? I believe I'm done.